Okay. All right, guys. Thanks for your patience. Okay, so we are mostly today in this section learning about what's called piecewise functions. I kind of like to compare piecewise functions to the Frankenstein monster. You guys know anything about the Frankenstein monster?
The actual Frankenstein's monster or the new?
Well, I think just the legend, the story behind Frankenstein's monster. Frankenstein is made from pieces of cadavers, right? So Frankenstein is a combination of several different people who once lived, right? So piecewise functions are pieces of common functions put together to create weird functions. Okay, so before we can take pieces of common functions to make them into weird functions, we have to know what those common functions are. So these are things you've learned about over the last few years, but we're going to review them. Okay? So this first one here is our constant function. So for a constant function, we just have y equals a number. So I could call it c for constant, or we could just pick a number to use as an example. What number do we want? Something less than 6 or 7. You guys don't want negatives? Just 4 is what I keep hearing over and over. You guys heard my. Okay. So, I don't color. So y equals 4. That's just a horizontal line at 4, and we call that constant. Like we saw on the assignment when we were going over that question today about y equals 6. It doesn't matter what the x value is, the y value is always 6. Same thing here. It doesn't matter what the x value is, the y value is always 4. It's a constant. Okay, then we have what's called the identity function. Identity would be y equals x. So every time we plug in an x value, the y value is exactly the same. So plug in 0, get out 0. Plug in 1, get out 1. Plug in 2, get out 2. Plug in negative 10, get out negative 10. What that ends up doing is creating a diagonal line through the origin. That's our identity function. It's linear, it's a line, just like we're going to talk about. Well, you're probably familiar with learning from other classes about a linear function where you can now take that identity function, you can add something to it, and it moves it up, changes the y-intercept. Or you can multiply it by something, and it makes it more slanted, it changes the slope, right? But they all come back to just this basic identity function. So linear, right? Kind of be another name for that. Absolute value would be the equation y equals absolute value of x. Now, whatever you plug into it, it doesn't matter if it's positive or negative, you get a positive value. So if we plug in 0, we get 0. But if we plug in a positive number, we get a positive number, kind of like the identity, the same number back. But if we plug in a negative number, we get a positive. So instead of the other side going down into quadrant 3, it actually goes up.
Teachers and students, please excuse this interruption. I need to have Camry and Carly Harris. Camry.
Quadratic. A quadratic function is where we have an x squared but no y squared. Because obviously if it had a y squared, it wouldn't be a function. Today we're talking about functions. So it's just the y is the x squared, not the y. I know you study these extensively in like Sec 2. So this is where instead of everything again is turned positive, just like our absolute value. Anytime you square a positive number, you get a positive number. Anytime you square a negative number, you get a negative number. But a positive number. So everything's going to go positive, but instead of it being that V shape like our absolute value, squaring it makes it go up at a different rate. And so we get that curved graph, because over 1 up 1, 1 squared is 1, but 2 squared is 4. So we get that curved U-shaped graph. So I wore my youth shirt today in honor of the parabola graph. Just kidding, I didn't even think about that, but there you go. Okay, y equals x cubed. We plug in positive x's, we get positive y's. Plug in negative x's, we get negative y's. But the cubed gives it a different rate. And so you should have studied this in Sec 3 last year. So it kind of ends up looking like this. I'm not being very careful with where I'm putting the points. I'm just trying to get us through this catalog of functions. You really need to make sure you know what these basic functions all look like. Y equals 1 over x, sometimes called our reciprocal function. It's also a rational function. Rational because it can be written as a ratio or as a fraction, but this one in particular we call the reciprocal function because it's just 1 over x, so it's the reciprocal of x. For this particular one, we end up with asymptotes at 0. And because you can't plug in 0, because you divide by 0. And you can't get 0 because there's a 1 on top. So we just end up with plug in positives, we get out positives, plug in negatives, we get out negatives. So it just ends up being a graph like that in quadrants 1 and 3. Usually I do an activity with this where I actually have you plot the points to discover what these look like. But I'm hopefully talking through them so that you remember them from previous years. You believe me that I'm telling you the truth, hopefully. Okay, so y over 1x squared. The only thing that does different from our reciprocal function, it's going to change the curve of it a little bit, but that's not the important part. The important thing is it's still going to have the same asymptotes. We can't plug in 0. But when we plug in positive x's, we get out positive y's. We plug in negative x's, we get out positive y's. So everything's going to be above the x-axis. So that would be like, here's our asymptotes again. And we have this piece up here, and this piece over here, approximately. I'm not stopping to plug in points, but you get the idea. Apparently I need to quickly answer my son if he can do safety patrol. Give me a second. Did I? Yes, I did. Okay. Okay, square root. Y equals the square root of x. Now, notice how this is just square root of x. It's not plus or minus square root of x. It's just, I said yes, yes, yes. He said okay, okay, okay. Right. We're not going to do both the positive and the negative square root of x. We're just going to do the positive because there's no minus sitting there in front of our square root. So because of that, we just end up with half of the sideways parabola. If it were plus or minus, it would be the entire sideways parabola. Like it's the inverse, it's the opposite of x squared. Does that make sense? Because squared is square root. We'll learn more about inverses later in this chapter, but it's not today. Okay, cube root. So cube root. Notice how this one starts at 0. So it doesn't go over here in the negative infinity zone at all. Cube root does, because the reason this one's restricted is we can't take the square root of a negative. But we can take the square root, the cube root of a negative. So that opens up our domain to all real numbers. Like that. So usually I stop and do the domains and ranges on these. Should we do that really fast?
Sure. Yeah.
It'll take some time. If we need to catch up a little bit on Friday, we will. Okay. So I'm just going to not write down if they're all real numbers. We're just going to say it. Move on. So all real numbers. No, wait, it's not. The domain is all real numbers. What's the range? That's the range right there, right? The range is just y equals 4. Okay, this one is all real numbers. Left to right for x, bottom to top for y. This one is x is all real numbers, left to right. But what about y? So the range would be from 0 to infinity. If I'm not writing it down, it's negative infinity to positive infinity. I'm just saving time by not writing it. Okay, quadratic, left to right. All real numbers, bottom to top. So the range is going to be 0 to infinity, just like it was for our absolute value. Okay, cubic function. All real numbers. All real numbers. Cool. This happens to be my favorite, the x cubed, because it makes a really nice geometrical advancement in our disco. There's a little preview. Okay, reciprocal graph. So our reciprocal graph has these asymptotes. So we have to split up our domain and range a little bit. So it's going to be like negative infinity, 0, union, 0 to infinity. And that's like both the domain and the range, right? D and R. Okay. This one has the same domain as the reciprocal function, but the range is just going to be from 0. So domain is going to be from negative infinity to 0, 0 to infinity. But the range will be from negative. Oh, wait. I'm doing that wrong again. I was doing bracket. Parenthesis. Yeah? Do you see why I had to change that to a parenthesis? There's an asymptote there. It doesn't include 0. So 0 to infinity, that's our y values. So left to right is domain, bottom to top is range. Okay, square root function. Domain, help me out. Where does it start from left to right? 0. Good. 0 to infinity. What about the range from bottom to top? There. 0 to infinity. Good. Okay, last one.
All real.
Yeah, all real numbers. All real numbers. All right, moving on. I'm not going too fast, right? We're good? So, you know what? I feel like maybe I want to stop the video at this point so that my videos don't get too long.